Welcome to the laboratory of DoDxAct's Limited. In this room, in the heart of Somerset, we help clients across the world to understand their processes, improve their printing performance through waveform development, and really get to grips with their R&D processes across a wide range of applications involving industrial printheads. We specialise, as you'll see, primarily in piezoelectric drop-on-demand technology, and today we'll seek to demonstrate some examples of printing with our equipment. And because of the nature of our business, those examples won't necessarily be cutting edge. They won't necessarily be what we work on normally. Because of reasons of confidentiality of all our clients, which are very rarely disclosed, we instead utilise our strong links with suppliers in the industry to bring you some examples which are not confidential. So they may not be the most technologically advanced, but what we're looking to do is to give you some insight as to how we leverage the capabilities in this room to help our clients. So, I must thank Sun Chemical and Agfa, who have both supplied inks for us today specifically for this future print demonstration. And I would also like to thank Adfos, who have loaned us a dryer whilst we're waiting for the one we've ordered to arrive. So, thank you, Mark, thank you, Phil, and thank you, Frank. Right, we're all naming and shaming done for now. I'd like to just describe a little bit more about what this room is for. So, we start with usually an ink that's been sent to us. We might be developing a waveform, or we might be combining materials to demonstrate what application performance can be obtained by pulling them together into a system. An example may be printing on aluminium or printing on a packaging substrate. And it could combine not just digital fluids, but analog ones, a paint, a flexo material, maybe a gravure primer. What we do is we react to our customers' requirements to give them the support they need and to fill the knowledge gaps that they may have. And as part of that, we also use this room for customised training. But today we're going to be focusing our demonstrations not on waveform development, but on print, and how we configure our systems to be adaptable to the range of needs that we address. So please, join us today on our adventure, keep watching to see how we do it, and I hope that you'll see the value in the collaboration that we've spoken about in our last Future Print contributions. For our first demonstration of DoDxAct's lab facilities and capabilities, we're looking at the image expert here. So this has been the first system that we installed and used to support clients, and today we've set it up with two printheads, the detail of which we'll look at in a minute, and that means we're currently running two hardware suppliers' equipment to drive those two printheads in parallel. One's driving on USB to the GIS, and the other one is driving a USB to the Meteor here. For the heads in question, we have a Samba printhead, which is being driven by the GIS, and next door to it we have a GH printhead from Ricoh. The Samba's running a UV ink, whereas the Ricoh heads are running aqueous. The ink system for the Samba is here, a little bit insulated because the room temperature is a bit lower than the jetting temperature, and we'll look in a minute in a bit more detail at that configuration. The idea is to print some samples using multicolour inks on aqueous, using two Ricoh GH heads, and then to overprint that with a UV ink. So both those ink sets are from fellow Future Print partners, Sun Chemical. Running for the GH head, we have the aqueous inks, normally intended for technical textiles applications, but today we'll be printing on paper. And then in the Samba printhead, we also have a Sun Chemical ink, but this ink is a UV curing clear varnish. And so we're actually just going to print it over the top of the aqueous inks as a demonstration. Now, to make that possible, we actually have to swap this Adfos dryer for this UV lamp. And so one of the components of trying to do support work on a variety of different chemistries is the ability to adjust to those needs. So on the DoDxAct's system, because we have this single belt and we're a little bit more limited for space, then that means we're actually going to remove a piece of equipment and then put it on again. In our next demonstration, we're actually going to contrast that with our home-built system, where we can actually we've actually taken a more modular approach, making things easier to switch. So what we have here is the data on the pressures of the GIS ink system being read in real time. And this is setting the flow going through the sampler printhead. So what we're going to do as our first demonstration is we're going to switch that to be the GIS jetting software, so the print controller, and look at the drops on the Jet Expert screen. So we're now onto the GIS jetting software. So we're going to start a job that prints all nozzles in the printhead. So that's all 2048 nozzles. And then we're going to pan across to the screen of the Jet Expert to see the drops firing. That's now printing. So you can see the drops appearing on the screen, and what's happening there is some of them are in focus of the lens, and some of them are out of focus because there's so many rows. If we look at the system itself, and what you can clearly see now are the drops being ejected around the sampler printhead, and then they're currently being taken away by the airflow of a fan and then caught in filter media just to stop us having to worry about breathing them in. But it's an example of just how much ink a sampler printhead can put out, and in this case it's only going a few thousand hertz. Right now, having looked at the drops on the screen and flying around the printhead, what we're going to do is we're going to switch to the GH, driven by the Meteor software, and we're going to do a print demo on the two colours with the Adfos dry unit. So I have to move from the head position for drop watching to the head position for printing. Now this is made a bit more complex by the fact that we have so many systems installed, so just have to make sure that our pressure control for the ink system stays intact. So now we're over the belt. So we're now in the print position. The belt's been set up with a substrate, and so before we print, all we've got to do is turn the Adfos into standby mode. So then it's warming up before it's then ready to go to full power and dry the ink as it comes through. So the conveyor is only set for a slow speed, and that's just to help us visualise what's actually happening. So, with no further ado, I'll turn on the full power of the Adfos, which will be a bit noisy, and then start the conveyor. I'll print. What we're going to do now is we're going to swap the Adfos unit here for the UV dryer from Integration Technologies, so that we can overprint the aqueous print we just made with the UV varnish from the sampler head. Now that's not a particularly interesting way to spend your time to watch me do that, so what we're going to do is record a short time lapse and share that with you instead. So, as we just showed, got the UV mounted, so it's time to try and make a print with the sander over the top of that aqueous print we did just a while ago. So the UV lamp here from Integrated Steroids is on standby, it's a mercury lamp, and that cures well at the wavelengths needed by this particular ink. On the side here, you can't quite see, I've got a controller which will open the shutter. So it'll be a shutter controlled lamp so that it's not putting UV light all over the place while in standby. However, I will need to change some of my PPE. I'll take on the spectacles and adopt something a little less conventional for winter time. So the shutter is manually operated. I'll start the belt and open the shutter and show you the result. There we have our DoDxAct's print with UV at the top. So, that concludes our demonstration with the Image Expert system. And you may be wondering, so what is interesting about some water-based ink with some UV at the top? Well, frankly, not much in my business. However, what it serves to demonstrate is that in solving technical problems related to industrial inkjet, it's necessary to leverage a range of equipment, whether it be printhead, whether it be ink system, whether it be UV system, and collaborate within the market in order to solve those problems and meet client expectations in terms of offering solutions. And not just advice, but demonstrating it in practice. It's those partnerships that we emphasised in our last sessions of Future Print, which are so key to the delivery of industrial inkjet solutions. And whether it be GIS electronics and ink systems, or Meteor electronics, at DoDxAct we are completely independent and will be led by what the client requirements are. Now, one of the reasons I demonstrated the Image Expert first is because it's a well-known solution in the industry for trying to meet the needs of R&D. However, I think we've shown already, particularly with changing over the lamp here, but also with how busy this area is and how constrained some of the equipment layout is when trying to do more complex tasks. But there is a bit of a limitation here. And for that reason, we developed our own more modular approach to augment what we can do. And it's that which we're going to show you next. In this part of the DoDxAct's lab, we look at the inks when they come in, or we make fluids for our own internal testing and understanding. We also have a drying oven here for drying prints and doing materials compatibility. So let's just look at what we're doing now. At the moment, there's a print in here. Print we made earlier of the DoDxAct's water-based. So if we're not using inline drying like the AdFOS that we showed, or perhaps the reaction of the ink is more longer term, then we can use the drying oven. And that keeps us adaptable to higher temperatures or very specific temperatures of post-treatment. We also use the oven for doing materials compatibility work. So it will be on long term then, at a lower temperature, looking at, for example, tubing or printhead compatibilities on behalf of clients using chemistries not yet proved in printheads. As a part of the ink testing of that, the viscometer is very important. So we've recently upgraded to the ICA viscometer here. Currently we're measuring the Agfa ink that we'll be showing on our Meteor-based system later. And the temperature is 45 degrees C. As you're controlling the temperature through this lower cost water bath alternative, working through this low sample size, extra low viscosity adapter. So we need less than 20 millilitres to make a viscosity measurement. And at 45 degrees C, we're getting a viscosity of 10 centipoise. If we need to modify viscosity of fluids, then we have some chemistry available to us that we keep in the laboratory. Diluents, for example, for UVs, or different types of solvents. But we also make simple chemistries using the mixer, and we can, of course, make those to specific viscosity, depending on the experiment. So the most important thing about this part of the laboratory is incoming quality testing, so that we understand what settings we're meant to be using in the printhead. Printhead specifications often give guidelines on viscosity, but actually showing which viscosity is at which temperature enables us to set the right setting in the machine. Or conversely, we can measure what we think to be the preferential jetting setting and then link that back to the viscosity of the ink. So, with no further ado, let's get on and look at some print equipment. Now we're looking at our other system, having moved some of the equipment from the demonstration we did before on the Jet Expert. I'll highlight where that's the case. So today we're focusing on print demonstrations rather than drop watcher or waveform. So we have an ink system at the end here of a Zar Hydra, and at the moment that's loaded with the Agfa Altamira Design BP Black that I mentioned measuring viscosity for earlier. Currently, that's recirculating through a Seiko printer. So, just so we can now see the majority of the system, I'm going to move the monitor across. The monitor is designed to be flexibly movable so that we can access different parts of the system, but still work close to whichever head we are actually using at that point. So it will slide along. As we see, the Seiko head is in this position. We have the pressure monitoring part of the Hydra ink system here, and the tube feeding down. The head itself is hiding from your perspective behind this. We'll cut some more detailed shots in a minute to show you some of the actual details. Those are also available in the blog I did before for future print. At the moment we're going to be doing a UV test, or well, very soon. And so mounted here we have the same integration technologies lamp we demonstrated using the Jet Expert system. In front of that, but a little bit out of sight at the moment, we have a road treatment head, which is a Spot Tech from Tantec, which we are renting at the moment to do some custom work and also for the purpose of this demonstration. We'll show those three components working together to print some bottles a bit later. The main difference with this system versus the Image Expert is the fact that it isn't just one head or two heads, but by allowing a more modular approach, a longer conveyor, we actually at the moment have 1, 2, 3 heads mounted. And as you can see here, at the same time as the UV, we have an Atos die mounted behind the X-ray head. So the idea is that you can very quickly and adaptably not just compare print heads, but also switch between them for doing different types of experiments. And we found, working on quite a wide range of applications for clients, this is one of the key things, to be able to change quickly between different requirements, particularly when you have ongoing project work. So as a result, the separation now between the head and the belt is much larger. And the key reason for that is the ability to print different types of parts. Ones which have greater form, or originally, for this system, to be able to put a 3D printing powder bed underneath the printhead. But what we realised was that extra space also allowed us to locate a drop watcher. So under here, just visible, with this collection container attached, is the Meteor drop watcher, which we'll be showing in a bit more detail again in a clip to follow. And the Meteor drop washer can actually be moved and used with each of the heads that are installed. In fact, we have more head capability for the drop washer and for printing than is currently installed here. So what we'll be doing in another little video section later is showing you how easy it is to change between them. Going from the RC1536 Seiko head to what is currently the DoDxAct's 1024 SA head to what is currently the Epson S800 head. And what we're actually going to do is we're going to swap the DoDxAct's head to a Gala and show you how easy it is to change over the head mounts in this modular system. As part of that, we'll be moving the ink supply of Hydra onto the Zara. And then, actually in the same time-lapse video, because these activities are a bit longer than just swapping over the drop washer, we're going to also change the Epson head here to the Zara 1201. And actually, the Zara 1201 is one of the first heads we got on this system, and we installed it because of the ability to do multicolour prototyping very quickly, which explains the final element here. It is the syringe at the end, which allows us to quickly syringe fill and then shoot ahead like the 1201. But our first demonstration is going to be printing. For our print demonstration, we're going to use the aforementioned Alpha ink and print on this bottle. No specific reason for this bottle apart from the fact it's big enough to mean that it can only be printed on this piece of equipment, and actually I couldn't do a print demonstration on the Jet Expert using this, but this isn't enough space. So first we'll mount it. So on our print table here, where we can expand the height wherever apart, simple scissor stand, we've got a jig that's holding the bottle stable. We have an encoder that does also acts as a product detect with a print. So all we need to do is give it some treatment. So first I'm going to go backwards, but with the corona on for treating. So the switch unfortunately stages all the way over here. Corona on. That's it treated. And then to go back the other way, we just have to go underneath the head. It will do a PD, and then I will operate the lamp, just like I did on the Image Expert. And just like the Image Expert, I'll change to this, just in case. So, as I said, just operating the lamp manually. So once I start the stage, there we have our print. So we've done our print demonstrations, but of course when printing something it's always good to be able to see the results, and although I waved from that view, I didn't quite get to inspect them properly. So we have a camera system here that's exactly for that purpose, and on it we have the Jet Expert print. We just put that under the camera, we see there's a few missing nozzles in the magenta here. Again, it's just a test head, but it's very easy to inspect. We've got registration and all the sorts of things that matter when you're doing colour-to-colour testing, particularly for a lot of the packaging applications where bleed between colours is an important part of optimising materials, like for primers. Another advantage of this, of course, is being able to inspect the head. Now, admittedly, not whilst installed, but usually, if you want to know why a head's not doing something it's supposed to be doing, you've usually actually taken it off already. So as an example, I'd have a used G8-20 print head here. I'm going to put that down, and then move the microscope up so we can see the nozzles. Although this is quite an affordable system, which makes the stand not as good as it could be, you can see that the camera system itself is very powerful. So once I zoom in there, I set the focus, and I can actually use a digital zoom and see quite a bit of nozzle detail. Because of the limitations of the height of this, then I'd love to be able to look at this print we just did, but I'll run out of such range. So maybe something for the future. That's our camera system. So for the next section, we're just going to briefly show how easy it is to change between the different printheads on this system. So currently we're on Seiko RC1536, I mentioned earlier, and we're going to now change to the DoDxAct's SG1024. So from running the Alpha UV ink to running a solvent clear. So let's just see the drops first on the Seiko. So this is the 1, first drop size, 2, second, 3, third. We haven't done any waveform optimization here, just what it came out like with the standard waveform. Okay, so without further ado, let's demonstrate how quickly we can change over. And the first step is actually to stop that printing and to quit the software. But we do that because we need to power off, and it comes up much more predictably if we turn the software off. Right, so without further ado, power off. Power off. And then we move the connection here from the HDK for Seiko to the HDK for the SG. Then we turn the power back on. Okay, so now we have to restart the software. And this is probably the most time-consuming bit, so bear with me for a moment. First we open the Met drop and we choose the new printhead. So the software is now initializing. Once that is complete, we open the drop watcher software. Whilst that's doing, we're going to move the drop watcher head itself. So here we could convey it along, but that means lifting the head up, so we're just going to move it manually. Of course, if you want it to be completely orthogonal to the camera, then it takes a little bit longer to set up. So if the software is open, so we turn on the power, and now I'll open the drop washer. And so with the drop watcher software, it takes a little while for the intensity of the LED to equilibrate. So I start the print to begin that process and press go on the camera. And immediately you see the intensity averaging out for the frames. Now the hardest thing always with moving from one head to another is finding those drops again in focus. So actually, I'm going to tilt the screen slightly to me whilst I change the focus, so it may not be so easy for you to see on the camera. So now we see some drops. And because on the SG head it's lower resolution, there's fewer drops on the screen, I just move that across. We've got 3. We've also got another row here. That's because we still have the 1 in 4 nozzles before, so that actually gets 2 rows. So if I change that to be 1 in 8 nozzles, and actually focus on the row that's still firing, hopefully you can see those drops now. And just to make that very clear, we can zoom in on those drops because they're a bit smaller than the last ones. So we draw an area of interest. And then we can zoom in on that. There's a drop, and that's how easy it is with this system. For our last demo, we're going to show how it's very easy now, not just to change the drop watcher between heads, or for printing even, but actually how to change heads over using the fact that the modularity of the HK system implemented by Meteor for their drop watcher on our system allows you to make multiple changes. So we're going to actually change the SG1024 control electronics and the head for ZAR 1003, and then we're going to change the Epson S800 here for the ZAR XJ1201, which, although discontinued, will now be in future the Ricoh TH5421 in this position when we want to do print prototyping. So let's show how that goes. And actually I'm going to speed this one up because it does take a little bit longer for some of the demos. We've only got a limited amount of time, but let's get started. It took a bit longer, and hence why we forwarded it, because it's longer than the video is meant to take for future print. So it was about 30 minutes. And what we've done is we've shut down the Seiko, restarted the Hydra, when connected to the ZAR, which is then newly mounted. We've done a new mount on the XG1201, filled it with a fresh ink, the same Sun Chemical ink as we used over there, and that's what's currently connected to the drop watcher. The AdFOS is here ready to dry the ink, and the UV has been moved here ready to print with the ZAR. But we've run out of time. So for the purposes of our demonstration, we have come to the end. Thank you very much for your attention, and I hope that you found it illuminating, and at least that you see the wide capability that we have at DoDxAct and the ability to adapt to all the different needs of the inkjet world. So if you've got needs or know someone who does, don't hesitate to contact us, because I'm pretty sure we can help. Thank you.